Hi, my name is Eric Stover. I'm the president of MQ Measurement Solutions, and I want to show you the M-Wave 339 IR interferometer today. So the M-Wave is a Twyman Green type configuration interferometer. We have a Heaney laser set up at 3.39 microns. We've got a nominal 1-inch output beam. The camera is a 640 by 512 pixel resolution with 15 micron pixel pitch. And we've got a continuous 1 to 6x zoom. So one of the key advantages of this instrument compared to some of our competitors is that we get very high resolution over very small apertures. And then we just use beam expanders if we want to go larger. So if you have like 1 inch or smaller, or ½ inch, or a couple millimeter sized assemblies, we can get with a 6x zoom starting at 25 millimeters. So we can go down very small, get nice high resolution data. Whereas our competitors tend to have a 4-inch or 6-inch aperture to start with, and then they have only a 3 to maybe 4x zoom from there. So we have a nice key advantage for small parts, getting nice high data resolution. And then we just use these beam expanders to come up to larger sizes. These just thread in and out very quickly. Here you can see another advantage is we get to keep the cost, the size of our optical components down for our F lenses. So again, it's nice for, infrared lenses are very expensive. We're able to use much smaller lenses to help keep the cost down. So here I'll show you a couple of the zooms. So we have motorized control over the zooms. If you can see up here, we've got this little germanium window. Here's there also a reference mirror. So this is an M switch essentially, which I'll talk about in a little bit. This is just a germanium window. So we can zoom in, it's about 1.5 inches diameter. We can adjust the intensity, we can adjust the focus, and it's all motorized. And then we have an aligner view mode. So if you want, it has a much larger field of view, so we can very quickly align a part and then switch back to the view mode to get ready to take data. The software package that we use for data acquisition and analysis is Reveal. It's made by Opera. It's a great software package for visible and infrared interferometers. The M-Switch accessory here that I'm using is just a standalone accessory. It works for visible or IR interferometers. We have 20th, 40th wave reference mirrors. But the goal of this is to be able to fold the beam from horizontal to vertical, either to save space or to help with accuracy on very thin parts that tend to bend with a horizontal with 3-jaw setups. And also for speed, so when you're trying to do maybe high volume type measurements. This is currently using, I think you can zoom in a little, this is a variable aperture, 3-jaw. It's 3-jaw, but it actually uses little lands to quickly adjust to variable diameter parts. Then we can protect the mirror or not and slide that in. But we also have this set up so we can just take off those 4 bolts and then put in a kinematic assembly. And then we have either customers can make up or we'll supply Delrin or aluminum little chucks set up. So this allows parts to be quickly put on and off with different sizes with finger holes in them. Also, this is great for windows and lenses, but you can also do assemblies in this as well. So people can make these up, put in their threaded mounts or bayonet mounts, whatever it might be, and line up a whole bunch of these. And then once that's set in place, they just pop it in and out. Right now you're seeing the setup for the transit wavefront measurement for windows on homogeneity, but we just take off these 3 bolts here, and then we can switch to use our XYZ tip tilt mounts. It just takes a minute. Sit down here, and then we put our vertical assembly on. Take these bolts again. I'll just put 2 in for speed of the video. So now we've got X, Y, Z, and tip tilt to align a null mirror, or we also have this accessory comes off and we have another one of these part holders, which then you could put the part up top and maybe put a null lens or a CGH in the middle if you want to measure aspheric parts. So this vertical accessory, we've got a 1-inch micrometer adjustment for fine adjust. We've got a 2-inch dovetail slide, and then we've got about 6 inches of travel. I don't know if you can zoom in or not and see the bolt spacings on here, so we can just adjust that bolt spacing and then flip it top or bottom. Same goes for the accessory for the part holder. So we can switch between measuring, windows and mirrors versus lenses and lens assemblies. So again, the interferometer, as a whole, works very well for measuring transitive wavefront on infrared materials, for doing homogeneity testing, transitive wavefront testing, flatness testing, or many of our customers use these for optical assemblies, in particular doing transitive wavefront performance of an optical assembly and looking at diagnostics. So the software is a full software package with Zernike analysis, Seidel. You can even do some MTF calculations on it, homogeneity, and such. So thank you for your time.